at a very early stage, I wanted to be a scientist. So the field was not defined, and maybe when I was 14, maybe I would have thought I would be like a Assyriolog, or trying to read this, cuneiform plates from Iraq and to understand what they were talking about. But of course, I found more realistic to do mathematics after the baccalaureate, and so then I understood it was very, very interesting to do mathematics. And because precisely I was in this university system, which was less selective than this preparatory school we have. And at some point in the second year, I found that the professor in mathematics was a little bit too shallow and too slow. So then I decided to do my own mathematics, and I found in the library a book written by a well-known mathematician in France, which is named Dieudonné, and he was one of the main members of the Bourbaki group, and one of the people who wrote most of the text written by Bourbaki, so very pure, very abstract mathematics. But for some reason, the same person had written a textbook for students on the topics in analysis, and in a completely different style, which is, I never understood actually what was the motivation. And in the book, which is called Calcul infinitesimal calculus, there were a lot of exercise to be done, and without solution and without indication. And I found exciting to try to solve this exercise by myself, so without a professor, just from the book. And this was almost like a research program, because all these exercises were difficult and without any hint or solutions. So I remember I spent the summer vacation in trying to solve these problems, and this was really exciting. And so I got really the excitement for mathematics during this summer. So for me, the excitement started when I was 18, I would say. Because before I was much more excited by comparison between all languages, like Sanskrit, Greek, Icelandic. So I was much more fascinated by that. Mathematics is beautiful, but mathematics is much more important than people think, because it's behind so many things. And of course, for the good and for the bad. If you are pessimistic about the progress, you can say, well, this is a dangerous game, but I would say this is, if you are optimistic, it's fantastic. I mean, this is remarkable how mathematics were powerful, and they started the modern Western civilization in a remarkable way. But of course, there are many drawbacks also. The starting point for me was a strange meeting I had in the Atomic Energy Center in France, because I was working in the Computer Science Institute of France, which is called INRIA, and so in this institute we were supposed to do a really interaction with concrete problems. And once we had a meeting with some people from the Atomic Energy Center in France, and these people are taking care not only on the nuclear plants, but also on the nuclear bomb. And so something happened in the 80s. You may remember that France was still launching some atomic bomb in the Pacific Oceans, in some atolls, which was extremely controversial. And at some point, the idea was to put the bomb inside the atoll. So the atoll is the top of a volcano, which is just slightly above the sea level. It's very flat, like 2 meters high. And once, because of the explosion, there was a landslide on the side of this volcano, which created a tsunami, and the atolls were almost entirely flooded by that. So these people were very nervous about the simulation, the fluid mechanics simulation of the tsunami, how a very flat area can be completely devastated by a tsunami. And for some other reason, I had been interested in the computational approximation of fluid motion. And for some reason, I had some idea about solving the problem, which was not very concrete. In some sense, this was more like, I think in German you say Gedanken, I mean, this is like a way of thinking of the problem, and I was not really successful in helping these people. Okay, it's just after, but the meeting was fueling some new ideas in my mind, and then by thinking about this problem, I end up with this interaction you described between the different fields of mathematics. Yeah, because this optimal transportation field was known in statistics, in probability, but it was essentially unrelated to my own field of mathematics, which is like partial differential equation, and I bridge and also made a connection with this equation of wind motion. So for me, it's very natural. The link was very natural, but for some people, it was very surprising. How can we put together all so different things, and motivated by a kind of, I would say, more or less not so nice military application, but in some sense I was very satisfied that I could get a lot of theoretical idea out of that, but at the same time I was not unhappy not to solve the problem. Okay, I think I was very lucky because essentially I don't remember any big trouble. I was very lucky, actually, I would say so. I would say the opposite. So I could tell you how many times I was very lucky. I think it's more relevant. So I think I was very lucky in making this strange choice at the beginning, choosing the university instead of the Grande École, because I think this helped me in some sense, in many respects. Also, I was very lucky in doing, so actually I benefit for bad events. So one of the bad events was this oil crisis that moved me to apply mathematics, and I think it was a good decision. Also, I had to do the military service, as we did at the time in France, and actually I managed to go to this overseas service, which was a possibility of substituting for the military service in France. So I was a kind of researcher in Mexico, and then I met a very well-known numerical analyst from the USA, Stanley Osher from UCLA. And then this started a connection with the USA through the University of California. And this was really helpful because this helped me also in my career. And the fact that at some point I moved from Paris to Nice in a research position was very, very good to me because this gave me more freedom. Because I had a professor position that I enjoy very much, but then this was a nice continuation to do research in the beautiful city of Nice, which was a little bit reminiscent of California for me. So actually it's more like a succession of luck. I don't remember. Okay, of course, when you remember things, typically you wipe out the difficult parts, but I think I was really lucky. Maybe my generation was lucky. For instance, we didn't have to go through this postdoc position that now the young people have to do. So I got a research position to do my PhD, actually. So it was a temporary position, but I was hired with a contract of 7 years to do my PhD and to continue research. If you think about the modern condition, we are very far from that. Maybe in France, some people manage to get research position at a very early stage, but this is very exceptional at the world level. This is due to the CNRS, the institution I belong to, the Centre National de la Recherche Scientifique, and I'm very attached to this institution, which is quite getting really unique in the world, I would say, which is able to provide stable position to people at the early stage. So my advice for a researcher would be to keep some strong personality and to avoid to be too much a follower, you know, because this is okay, it's probably a wrong advice I'm saying, because it is certainly the most profitable thing to do is to be in a good field with very good leaders in mathematics and to be a follower of them. But I would prefer to advise to stay free as much as possible and to try to open your own track, I mean, of research. not to be too influenced by the community. And the problem, okay, maybe it's a pessimistic view. I have the feeling that nowadays people are really constrained by a lot of strange rules like contracts and things like that. So they are pushed to be, this is against independence, I think, very much so. And anything that could prevent people to depend on the organization managers, I think would be good. So I would like that people, the young people, at the collective level, would fight to preserve the independence and not to be ruled by crazy management requirements. I cannot tell you so much because I don't think there is any planning actually. This is also something that maybe the management of science doesn't understand enough. That's it's very hard to plan actually in this business. So if you have too much planning, it's bad sign in my opinion. So the planning should be quite limited because you should be ready to shift to some other idea quite swiftly at any time. But of course, since I love computation, I would be really, it's not planning, it should be more like a dream. So if I could be heading a methodology to solve some big computational problem in the field I like, I would be really happy about that. But this may be too much a dream. So I'm more related to theoretical studies than that. But I would be very proud to design a new algorithm for many possible applications. So this is something that is always driving me.